For decades, physics has built its foundation on a rigid grid. But under the extreme forces of the subatomic world, that flat background shatters. Quantum chromodynamics models the strong nuclear force through the exchange of gluons. The mathematics treat these gluons as discrete, zero-dimensional force carriers, interacting across a mathematically flat stage. The energy densities required to bind quarks together are immense. To contain that much energy, the local vacuum must be severely distorted. General relativity requires spacetime to be a continuous curving topology, yet the Standard Model ignores this local distortion entirely. The theoretical framework of infinite fractal descent addresses this geometric contradiction. Under this model, spacetime functions as an active, continuous field governed by scale-invariant logarithmic geometry. Within this geometry, a particle exists as a structural bottleneck, a localized microvortex where the geometric density of surrounding space compresses toward a central coordinate. To prove this mathematically, we have to construct the vacuum from its specific irrational axes and use those axes to derive the strong nuclear force without relying on the standard strong coupling constant. Achieving true unification requires treating the vacuum as the primary structural architect, dictating the physical laws at every scale. In the infinite fractal descent framework, the vacuum is a medium under constant thermodynamic stress, tensioned by foundational numbers. This diagram illustrates the three specific irrational axes that dictate the baseline topological resistance of the vacuum: the Golden ratio, pi, and Euler's number. The Golden ratio acts as the axis of recursive growth, stabilizing the fractal layers as they continuously fold inward. Pi provides the mechanism for circular closure, governing angular periodicity to ensure the vacuum maintains its structural shape. Euler's number controls the depth of exponential scaling and vacuum drift as energy translates across different magnitudes. Together, these three irrational spines construct the curvature comb. This is the structural grid that filters and distributes all energy flowing through spacetime. The total topological state of any given coordinate in the vacuum is dictated by the superposition of phase waves traveling along this specific dyadic hierarchy. What observational physics has historically treated as an inactive void is actually a precise, mathematically tense fabric. This tension is the prerequisite for all physical interactions. If the vacuum is a continuous web of intersecting waves, subatomic matter must be redefined. This topographical map demonstrates the core assertion of signal field theory. It shows that subatomic particles are coordinates where the phase waves of the curvature comb perfectly overlap to create a localized minimum dip. We call this exact coordinate of simultaneous smallness across all three axes a valley of alignment. For this valley to persist without dissolving back into the surrounding noise, it must operate within a strict mathematical threshold defined as the Inesca constant. The Inesca constant quantifies the irreducible phase drift between the logarithmic spiral and the integer lattice. It establishes a laminar buffer, which locks the interference pattern in place. Once locked, this stabilized node of high topological tension becomes a torsion singularity. This serves as the geometric replacement for the Standard Model's definition of a particle. The solidity of subatomic matter is a result of a stable, predictable geometric interference pattern trapped strictly inside a numerical envelope. The mechanics of a torsion singularity apply directly to the behavior of quarks and the gluons that bind them. The geometry here is governed by the rate of descent, a value representing the universal pitch of the logarithmic spiral. This determines the rate at which spacetime compresses, moving inward toward a microvortex. This is the equation for the fractal density constant. By tracking how topological action tension interacts with the internal scale ratio along this 3D curve, we can define binding strength purely through geometric tension. Evaluate the high-resolution limit of the formula, where the internal scale ratio pushes toward infinity. As the ratio scales to infinity, the denominator within the formula expands, driving the overall topological tension down to zero. This mathematically defines asymptotic freedom. Quarks move freely at close ranges because they align with the smooth, low-tension internal flow of the fractal geometry. Shift to the macro boundary of the vortex. As the internal scale ratio compresses, it approaches the universal rate of descent from above. The denominator approaches zero, causing the topological tension to spike toward infinity. the vacuum exerts extreme geometric resistance. This infinite tension creates color confinement. When the vacuum chemats stretch further, it pulls ambient energy from the surrounding field to manifest a new stable geometry, a process known as hadronization. Asymptotic freedom and color confinement represent the strictly necessary geometric limits dictating the boundary of a collapsing local space. If the universe operates on a continuous logarithmic spiral, the geometric rules governing subatomic microvortices apply equally to macroscopic structures. Scale invariance implies that the topology repeats across infinite octaves, provided we account for the rate of descent between those octaves. By mapping the radius of a microvortex through the universal octave separator, the magnitude of omega, we arrive at a radius identical to a cosmic event horizon. In this framework, a subatomic gluon vortex is the geometric equivalent of a macroscopic black hole. Because the geometry is self-similar across these magnitudes, the strong nuclear force and gravitational curvature are the same thermodynamic topological tension, merely observed at different fractal resolutions. This equation displays the mapping between these scales. It links the effective radius of a microvortex to a black hole's Schwarzschild radius through the logarithmic descent mechanism. By scaling logarithmically, this relationship allows event horizons to exist natively at both the quantum and cosmic levels. Under this paradigm, black holes act as recursive dew points, condensation nodes that funnel compounded local curvature back into a state of pre-formed potential known as white space. This framework offers a testable physical prediction. Hawking radiation emitted from a black hole should display a measurable energy deficit tied to the residual interference of the prime curvature comb. Bypassing the point-particle paradigm eliminates the historical schism between quantum mechanics and general relativity. The universe functions as a single continuous structure, orchestrating its own thermodynamic tension downward through infinite logarithmic steps.